Dear students, in the previous sessions, we have seen about what is a priori algorithm and what is FP growth algorithm and what is techniques in both the algorithm, what is the challenges we faced in two algorithms and what are the advantages and disadvantages and what are the comparisons we have seen in the previous classes. Now, in this session, we'll see one example how to work with the same a priori algorithm as well as the FP growth algorithm. See here, this is an example they have given it, an algorithm for generating a strong rules from frequent item set. This is the transaction ID. You see 5 transaction IDs they have given. 1, 2, 3, 4, 5. In transaction 1, they are given the item bought as M, 0, O M O N K E Y. In transaction 2, T O N K E Y. In transaction 3, M A K E. In transaction 4, M U C K Y. In transaction 5, C O O K I E. So like that, they have given one tabular column, that is a transaction they have given. They are asking you to find the frequent item set by using a priori algorithm and as well as a FP growth algorithm and compare the efficiency of the two mining process. Now, list, that is one thing they're asking you, and second one, list of all the strong association rule with support yes and confidence C matching the following meta rule, where X is a variable representing customers and item, where X is a variable representing customers and items, denote the variables representing items, that is A comma B. How to represent is for every variable X transactions, for every variable X transaction, if you take that X buys the item 1 and X buys the item 2, which implies X buys the item 3 with the support count of S comma C. So we have to prove it with the all the transaction. Suppose if X is buying the item 1 and X is buying the item 2, then obviously the X has to buy the item 3 with the support and confidence count. We have to prove it. Okay. Now this is the database, it has been given to you. Now you have to answer for this query. Okay. Find all the frequent item set using the a priori and FP growth respectively. Compare the efficiency of the two mining process. This was the question asked by you in the subdivision A. See subdivision A, find all the frequent item sets a priori and FP growth respectively and compare the efficiency of two mining process. This is the first question it has been asked. If come to this one, see here, M, in how many places it has happened. In first transaction, M is there. In second transaction, there is no M. So in third is 1 and next one is M. So M has happened 1, 2 and 3. So the value of M is written as 3. Then come for O. O is happened as here 1, 2, 3 and 4. Since it is 4, but it is a repetition. So that's why we are not able to, we are not counting here as a 4. We are taking 3. I'll repeat once again. You should be very careful if doing such type of problems over here. You see the same item has been repeated, but item is only 1. So in that case, I'm not taking the count of O as 4 here. So because it's all the transactions belonging to the same thing, so there's a duplicate value. So O value is 1, 2 and 3. It is not supposed to be 4. So that's what we are taking O value as 3. If we take it as a N value, see here 1, 2, the value is 2. Okay, like that we are taking the value of K. K is happened here in 1, 2, 3, 4 and 5. So 5. Then E value is 1, 2, 3, 4. So the value is 4. And Y value is 1, 2, 3. So the value is 3. And similarly, D value is 1. So you are taking the value as only 1. And A value is also 1. So we are taking the value as 1. And U is also taking the value as 1. And C is taking the value as 2. And L is taking the value as 1. So like that, first we have to generate the candidate key each and every time how it is going to be occurred. Okay, that's what 3, M is 3, O is 3, N is 2, K is 5, E is 4, Y is 3, D is 1, A is 1, and U is 1, and C is 2, and I is 1. So like that, we have to find out how many alphabets are there and how many times it has been repeated. That is the first step. So we have find out the first step. Now from this, we have to generate the list. Now, what is the minimum support count? It has been given for us is 3. Let us take the minimum support count has been taken for as a 3. So here, so while generating a count, see here, we are not taking the value to be 1 and 2 are not included. So here L1 is taking only the alphabets which is equal to 3 and more than 3. So we are taken M, O, K, E, Y. So only this alphabet is matching. So we are taking only these values. So from this, we have to take a combination of two items. This is a single item which is following a support count value. So with that, after pruning the unwanted things which is not matching over here, then it has been taken for the next level. So this is only following the minimum support count. Now what we have to do is we have to combine this alphabets. So M should be combined with O and M should be combined with N and M should be combined with K and M should be combined with E. Like that you have to make all the items one by one. So like that we after the combination of 2 we are getting the value as M, N, K, E, Y. So now we have to frame. See like this, I'll repeat you once again. So now all these items which is having a value as more than 3, that will be 3 or more than 3, that will be taken for the next level. So from this level we have to generate the two items, that is MO, MK, ME and MY. And then again OK, OE and OY. So similarly KE and KY. Then EY. So again we cannot go for YM because MY is there. So it is a repetition. So we have to stop here. So MO, MK, ME and MY and OK, OE and OY. Like that we have to combine two items. Now we have to find out this combination is existing in the database. Suppose MO should come together. So it is coming only one place. So I'm taking only MO value as 1. Similarly, we have to find MK is occurring in how many places. So I told you it is not a mandatory, it has to be come together. So it can be anywhere scattered in your database. So MK, this is one place. MK, this is second place. MK, this is a third place. So this combination has been occurred in 3 spaces. So I'm getting MK is 3. So similarly, ME is occurred in how many places? Like that we have to find one by one. So this is one place and this is 2 place. So it has been occurred in 2 place. And MY, you see how many times MY has been occurred? Here one time it has been occurred. Here it has been occurred another time. So we are getting MY as 2. Similarly, OK. See, OK is appeared as one time. This appeared as 2 time. And this appeared as a 3 time. So we are getting OK as a 3 time. Now, OE. If you see, OE has occurred at one time and here one OE has occurred at a second time and here one OE has occurred at a third time. So like that we have to combine the combination of all the two variables, two data, two items. Like that we have to combine together. Then later we should find how many thing is matching in our support count. So the value which is less than 3, suppose MO is 1 here and ME is 2, MY is 2 and OY is 2 and EY is 2. So all this data has to be eliminated for the next iteration. So after that we are eliminating the list from the candidate item set, and then we are moving to the next level. So that is your L2 level, where MK is 3, OK is 3, and OE is 3, and KE is 4, and KY is 3. So like that I am eliminating all the items one by one. So from that we are going to convert to the 2 item set in the 3 item set. So here if you see, we have first scan we have taken the single item set. In the second scan we have taken the combination of 2 item set. Now in the third set we are going to take the combination of 3 item set. So here you see MK is mingled with MO. So here again like that, this combination you have to take. That one is OKE and OKY. So like that, without duplication, we should take a 3 combinations. Okay. Okay. Then now we will be finding the how many times this OKE and KEY is occurred. You see here. Here O is there, K is there, E is there one time. Here O is there, K is there, E is there second time. So like here also O is there, K is there, E is there. So we are getting a 2 times. O, K, E is 3 times. So 3 times it has been coming sequentially. And one more thing I want to tell you, this variables can be in any order, no need for the sequence of one by one. And next one is KEY. So now KEY, you can see here, one time you are getting KEY. Second time you are getting KEY. So here and all only KE and is there, Y is not there. So this we cannot take it as a third combination. So if we come here, KEY is happened for twice. So in this one, which is having a eliminations, that has to be removed because our target is 3 and more than 3. So suppose what happened here, this 2 will not be taken for a consideration. So we will get the value as OKE is 3. So this is the way how it has been saved in your database. Okay, now this is how the a priori algorithm is works. Okay, if the same algorithm FP tree is working, here also the same combination only. You can see how many times a K is occurring, like a root node we have to put. From K, how many times C is occurring, first you should find out. So as you know, it is in an ascending order. In that way, you have to find out the link over here. If you see here, K is occurring at 1, 2, 3, 4 and 5. So K will be having the largest value. So in the descending order, K will be coming as a first. So that's what K is having the value as first. Then if you see E, 1, 2, 3, 4. So E will be having the 4. So like that we will be keep on tracing the value. So here also we are not taking the value which is less than 3. So like that we are framing the tree. Now in the combinations how we are making, if you see, so after eliminating everything we are discarding the values which is not equal in the tree. So suppose after that we are arranging in the order, that is E, M, O, Y. So these are all the items Y has been combined. See, Y is combined with what are the flow of this Y, if you see, K, E, M and O. So it is happening as a one time. So next we have to see where is Y here. How this Y is getting K, E and O. So we are getting the value as here, second path. So again the third path, how it is coming, K, M, L. This is, sorry, K and M. This is the another path. So your Y can be reached with the 3 paths. One, this one path, and this 2 path, and this is the third path. So like that it can be combined. Similarly, if you see O has been taken this path and this path. So if we take in this path, so you'll be getting K, E and M. So here if you taking K and E, they got it. So similarly M. So M, where is the path over here? Here. So you have to go back to K and E. So similarly, where is the M? Here. So it has to cross the K and then come to M. So like that, we have to find out each and every letter one by one, and you have to make a conditional pattern base. This is the base to reach. So from here, what is the size of the construction tree means? So what is our root node? Our K is the first condition node. So how many times your K is occurring here? 1, 2 and 3. So 3 times you are writing. So here, how many times your K is occurring? K here, here 1 time, here 2 times. So 2 plus 1 is 3. So K is occurring 3 times. So similarly, E and E here value is 1 and here E value is 2. So E is occurring 3. So here also if you see, E is occurring here at 1 time and here occurring at 2. But here it is not there. That's why we are not taking the value of E, because our support count should be 3 and more than 3. So here also if you see, K it's occurring 3, but E is occurring only once. E is occurring here 3, 1 plus 2, 3. So we are taking 3. If you see M is occurring only once. That's why we are not including the M value. So similarly, if you see, this is the way how we are framing. So here also K is 2 plus 1, 3 and E is happened only 2. So we are not taking the E value. So if we take a K, it is happening at 4. So K is 4. So like that we can make a condition tree with the probability value. Now frequent pattern for this one is how many patterns we can combine this. So KY can be combined with 3 and KO can be combined with 3 times. EO can be combined with. So this is the way how we are combining it. K, E. See, K can be combined with Y for 3 times. Similarly, K can be combined with O for 3 times. So similarly, E can be combined with O for 3 times. So KOE can be combined with 3 times. So similarly, K can be combined with M with 3 times. KE can be combined with E with 4 times. So efficiency comparing, if you see, now we have seen both the algorithms. In efficiency comparisons, you can see a priori has no multiple scans of the database, while FP growth builds the FP tree with a single scan. Okay, if you see, a priori has to do multiple scans of the database, while FP growth builds the FP growth with the single scan. See, if you see here in FP a priori algorithm, we have done a different scans. But in a priori, in FP growth, only one table column, we have find all the values. That's what they're telling. A priori has to do multiple scans of the database, while FP growth builds the FP tree with the single scan. So candidate generation in a priori is expensive because we are having more number of scans and it has to be stored in the database. Then FP growth will take a less number than you're comparing to a priori. Okay. List of all the strong association rules with support yes and confidence C, matching the following meta rule for X in a variable representing customers and item denotes the variable representing items. This is what we have given in the question. So if you see here, transaction X buys the item 1 and X buys the item 2, definitely they will be buying the item 3 also. That's what we are telling. The 3 items, if K, O and E. So the value is we are getting as a support count of 6, 0, 6, 1. So it is matching for this rule. So we are telling it is an association rule which is framing in the given database. Okay, this is what we have seen with the same problem. We have come across the true concept. One is your a priori algorithm and second one is your FP growth algorithm, and we have comparison the two things and find the solutions over here. So we'll stop here. We'll see the next class in the next session.